Okay, let me start the recording. All right, ladies and gentlemen, welcome to ADS532 Z2 class, and welcome to our Master of Science in Data Analytic program. I first introduce myself. My name is Stuart Huang. I earned my PhD in Applied Statistics from University of California at Riverside, and that's actually where I'm living. Of course, I travel. I enjoy traveling, so down the road I may have different class schedule for you, like in a noon time or 1 p.m. PM. Sorry, 12 or 1 p.m. starting time might be. We'll figure out if that's possible down the road. But for the first 3 weeks, we should be able to do it at this time. Okay, which I think should be good for you. Okay. Okay, and so I have been teaching in higher education since 2007 until now. Hi, Patrick. Welcome. Yeah. Okay. So teaching statistics and data analytic courses is what I do. All right. And I enjoy teaching. I enjoy the interaction with students for statistics, data analytics, big data, this type of courses. Okay, so this is me, and I'm with BayPath since 2018. Okay, so for at least a year. I also teach at other universities. Actually, I'm associate online associate professor at the University of Maryland as well. Okay, all right. So that's get into the course material. Let me share my screen with you. Excuse me. Okay. Can you see my share screen?
Not it.
Really? Let me see. Not yet. So none of you can see my share screen yet. How about now?
Yeah, I think yes. Yeah, I can see that.
Okay, good. Okay, this is our Canvas account, and I believe that you have all access to it. And in this account, you will see a lot of the useful resources. You will see welcoming message. You have an idea what we will do during this semester. Okay, and yeah, you should refer to the course syllabus, and you should have this is the textbook that we will be using. I encourage you to have a hard copy, or just buy a cheaper e-textbook. Of course, I have posted some available, make some available in each modules. So you will see. I will show you, but I still encourage you to buy the textbook. Okay, it's a good one, and we will use this textbook throughout for 2 semesters. I mean, each semester is 8 weeks for 2 semesters for ADS 532 and 533. This is a more challenging course than 522. It's sister's course because we will cover more theoretical and mathematical statistical materials. Okay, so this is what we will do. All right, now we will cover, if you click on the course syllabus, if you click on the course syllabus, you will see, sorry, not this one. Okay. You will see the more details, and we will cover these materials. All right, let me see. Which one? I think assignment and discussion. I think this. Oh, sorry. This one may not be the most updated because I have updated several times, and let me use this one. Sorry. I have updated it, but okay, maybe this is correct. I will let you know. Okay. Anyway, our assignment cover 43%, and final and discussion cover 35%, and we have a midterm art project and final art project. Okay. We will use art throughout this course, and actually the textbook itself has a lot of R coding instructions included, and these are the chapters that we will cover. We will focus on chapters 1 to 6. Okay, we'll cover descriptive statistics, probability theory, and sampling distribution, sampling estimation, statistical estimation, and then hypothesis testing. Okay, these are the from descriptive statistic to inferential statistic. Okay, and we'll approach these theorems while learning R, while applying R to them. So you will have 8 weeks to use R to. Sorry. Sorry. Excuse me. You will have 8 weeks to work on your assignment using R. Okay, and let me see. So this is a list of all your deliverables. For example, Module 1 assignment and Module 1 discussion. Basically, each week you will have 2 deliverables, which is weekly assignment and weekly discussion. For assignment. Okay, so this is first Module 1 assignment. Module 1 assignment, you will work on 2 questions, 3 questions. I made it pretty easy for you, and I give you hints. Okay. And you should refer to the hints here to work on them. And actually, if you also watch this video using R for descriptive statistics, you will see all the comments, all the functions that you need for R is there. It's all already included, and so should be very straightforward and nothing too challenging. Okay. And all those are quoted from the textbook. Okay. Then so you have assignment. You have assignments. We have how many assignments? 1, 2, 3, 4, 5, 7 assignments plus a midterm art project and final art project. So that including project, you have 9 assignments, and then weekly discussion. For weekly discussion, you shall make an initial post, but about at least 200 words is not too much, and then at least one response post to others. Okay, because we don't have too many students in class, so I don't require you to post too many, but at least two. One for your own answer to that discussion question. For example, here it says, please refer to chapter 1 in textbook and discuss the following questions. Give some your own examples of quantitative and qualitative data. Give examples cross-sectional time series data. Okay, discuss how you will collect different type of data. What differences do you want to derive from each of these type of data? Okay, so answer these questions accordingly. All right, and based on your study of the materials, of course. All right. Okay. Let me see. So these are the assignments, and okay, let's get to the modules. So I have posted our modules for our resources. How many of you have used R before?
I have.
I have, yes.
1, 2, 3. Oh, okay. Oh, most of you have already. Okay, that's good. That's good. Okay, great. And in case you don't have it, it's not hard to learn it from scratch. And we have a lot of useful materials here, including introduction to R. Click on this link. You will follow the instructions, download it, and install it in your desktop. Or you can use RStudio. I don't use RStudio that much. I just use R, and that's good enough for me. But many of my students, they use RStudio. Okay, and when you click on the PDF file, they are books, e-books for learning R, and handbooks as well. So these will give you sufficient material to learn if you want to go deeper. And actually, our homework doesn't include that much, so they are sufficient for you. And I want to show you this a very useful video. Maybe I'll play. It's just 4 minutes, okay? And you will see all the functions that you will need to answer one of the longest question. The last question of the 3 questions I have for your assignment. Okay, so when you click on it, you'll see how to let me see. Okay. Mhm. Mm-hmm. You see the 5 summary statistics that you need out there. They are the quartiles. Okay, this is how do you calculate mean, how do you calculate median, how do you calculate variance, and how do you calculate the standard deviation. Mm-hmm. This will be used in your bucket plot. range is maximum minus minimum. Um, yeah. So the difference, the first one shows you the maximum and minimum, but the range actually should be the difference between the two values. Okay. Mhm. Okay. Uh, I will stop it here just to show you that I prepared this for you. So when you go to the assignment questions, um, which is assignment one, which is assignment exercise in exercise section 1.5, a special 1.5.9, where you are required to show all those numbers. You will be able to do them. All right. And also, I have made available some other if you have used R before, then you know the first step is to read your data, or you can type the data in since all the numbers are small. But in the future, you should be able to read the outside exterior outside data to import data into your R. Okay, instead of typing everything manually, instead of typing everything manually, 1 second. You one. Okay, okay. So um, this is basically the first assignment. All right. Now let's go to module one. Let's go to module one. So where you can see, I have make an introduction area for you. So you should post a brief introduction of yourself, your name, where do you live, where are you from, what's your expectation for this program, and so forth. Okay. So we know each other, and better that we can help each other to succeed in this program. This program is not designed to fail you. That's why I don't have midterm tests or final tests. I use a project instead, and the assignments are all doable. So don't so it's designed so to that you learn, not to fail you. I can foresee that most of you will ace a class with satisfactory grade. Okay. Um, then you post your discussion here under the discussion that I have just shown you before. All right. Okay. All right. Then topic one is about descriptive statistic. And I posted the material right here where you can see. Of course, I still encourage you to purchase a textbook, but I made it available here. Okay, so the chapter one, we have basic concepts, sampling scheme, graphical presentation of data, numerical description of data. I will show you a website as well. You can use Excel, and because Excel is really handy. Okay, it's not as powerful as R, but it's very handy. In many, we all know it that R there's no such a steep learning curve as compared to R. Okay, so you should read the material. Oh, actually, the sections I have mentioned here in descriptive statistic, this section. Let me see, right here. 1 second. Okay, yeah, you only need to cover these 4 sections, 2, 3, 4, 5 sections, okay, and then go from there, okay, and then work on your homework assignment. Of course, you are expected to go over all these materials, and then in addition to my lecture. But if you can only put in minimum amount of effort, then the best way is to go directly to the assignments, and then come back and focus on the sections that talked about those assignments. I mean the questions. In this way, you may pinpoint on your question. Okay. But the best way is to go over the material first and then come back and work on your assignments. Okay, so that's, let's see. And here, lecture PowerPoint files, they are just graphs, okay? They are mostly graphs. So not having a lot of contents. Let me see. Yeah, as you can see, is pretty succinct. Okay, and I will go over this maybe. Let me see. Oh yeah, I used this before. For my other class. So you can go over this, and you will be able to see how to do the graphical way of presenting it. As I mentioned, obviously we won't be able to cover all the material that we cover, but we will definitely cover the most important ones. For example, let me see. I'll leave the descriptive statistic part to you. All right. And in terms of types of data, we have qualitative and we have quantitative. Qualitative is categorical, quantitative is numerical. I think that those are, one is names, and the other one is are numbers. And numbers, they can divide them into discrete or continuous numbers. Discrete are like integers, and continuous include the decimal places, so that's why they're continuous. For example, measuring of length is continuous. Measuring of weight is continuous. But counting how many students in the class is discrete. Okay, and so forth. All right, and sampling schemes, we have different type of sampling. I will leave this to your own study. Okay. Let me see. Okay, these are the different. Make it smaller. Okay, these are the different type of graphical method to describe your data. For example, we have bar chart, Pareto chart, pie chart. And these, the first three are for categorical data. Stem and leaf, histogram, and box plot, they are for numerical data, for quantitative. Okay. And this is categorical. You see the categories. Categories that by themselves they are quote unquote intervals. So it's easy that you just count how many belong to MC. Okay, how many belong to EI and so forth? How many belong to FD, CBI, AU? Okay, whatever the customer goods. Okay, and then count how many of them there. Out of, and then divide that frequency by the total numbers of observations in the data set. You'll get a percentage. Okay, this is a bar chart for showing you the percentage and proportions. And proportion is also percentage. Percentage, proportion, relative frequency, they are the same essentially. Okay. All right, and pie chart, you can convert the bar chart to pie chart. And these are the percentage in the parentheses. They are their percentage or relative frequency. Okay. Another graphical method for describing data is stem and leaf. Stem and leaf. So you see these numbers. The original data set is what? 68. Meaning as unlimited. Okay. The suppose this is data set 68, 75, 78, and so forth. So how do you convert that to a stem and leaf? What you do is to chop the data into two parts, 66 and 8. 6 actually stands for 60 plus 8. So you can see that's why you have 6, 8, and divide by a vertical line here. 6 stand for the intervals from 60 to 69, and then what? 7 stand for the 70 to 79, and so on and so forth. So actually, the stem stand for classes or intervals between equal intervals of equal width. Right, so you have 60 to 69, and all numbers that fall within 60 shall be written on the right hand side. Now here we only have 68, which fall in the range of 60 to 69. So your frequency is just 1. So on and so forth. You will be able to show a frequency distribution, right? In a way that's laid out in a landscape format. Okay, and you can see the frequency and then the distribution of your data. Okay, that is stem and leaf. But if you rotate the stem and leaf counterclockwise 90 degrees, it will become what? You will look like this here, and that will be called what? That will be histogram. There will be histogram in a real sense. Okay, so there will be histogram, and that shows you you see the histogram. So stem and leaf and histogram actually show you same information. Only histogram is a little bit more complete and complicated because stem and leaf can only show you the frequencies, but you can turn the frequency in the histogram to relative frequency. But relative frequency is actually percentage. Percentage is also proportion. So that is why for histogram is more useful. Another very useful plot is what? Is box plot. Why box plot is useful? Because it shows the 5 summary numbers. Okay, what are the 5 summary numbers? Q1, Q2, Q3, and Q4. Q1 is the first quartile. There's 25th percentile. Q2 is the median. Q3 is the 75th percentile, and Q4 is the maximum. Q0 is the minimum. Then you have IQR, which you just saw in the video. IQR is what? It's the difference between Q3 and Q1. Okay, you see that. The difference between 2Q two quartiles is IQR. Okay, and can you use R to calculate IQR? Yes, you just saw it. Just use IQR. Can you use R to calculate the quartile? Yes, you use quartile, and so forth. All right, so in addition to these 5 numbers, you see we connect the Q1 and Q3 with the in a box, and the shape of the box shows the variation and spread of the data. And we also have whiskers to connect the Q1 to what the minimum within the 1.5 IQR here. There's a minimum number connecting that point to Q1 will be the whisker on the lower side, and you will do the same thing to connect Q3 to the minimum within the IQR on the upper end, upper IQR. Okay, upper fence we call it. Actually here, sorry, here 1.5 IQR. We will give the other upper whisker, and this shows you the box plot. And in a box plot, you can identify outlier. Any value that lies below or higher than the IQR fences will be classified as outliers. But some textbook shows define the circle. You see the circle one that lie outside of the 3 times IQR on either side. Those are extreme outliers. Those lie within the first and the 1.5 IQR and 3.3 IQR. They are mild outliers. Okay, so those are more detailed. Anyway, some just classify that in general as outliers. Okay, right. And the difference between Q1 and Q3 includes 50% of the data. So the box plot is useful in that it includes 5 summary number, the distribution, the variation of the data to display your data. Okay. Let me see. Okay, and then we have a probability and histogram. As you can see, I mentioned that relative frequency is actually proportion. Proportion is percentage, and that is the precursor or the foundation. Eventually, that leads to probability. Okay, leads to probability. But what is cumulative probability? Cumulative probability is, cumulative means you add one on top of the other from the bottom of from the lowest value of the data. Okay, so in this case, instead of histogram, the cumulative probability will be the height of this one. Actually, this is frequency, but if you turn this to relative frequency, and then add the second one, the first one on top of the second one, and then the first 2 on top of the third one, and so on and so forth, you'll get cumulative probability. Because relative frequency is probability. Okay. All right. So by the way, in addition to R, there are also other useful material which are very handy. When I say very handy, means you can easily copy and paste the data without having to use the functions to read the data from your desktop and so forth. So it's pretty handy. You don't always need R to do so many things. Actually, if you use R, if you use Excel, you can get all the descriptive statistic in one setting. For example, this is Excel, and if I randomly create a set of numbers, for example, okay, these 6 numbers, and I install, and I believe most of you have installed the data analysis tool pack in it. So if I say data analysis and then descriptive statistic, okay, then I select the data in this range, and then select the output area to be, let's say, here. Okay, and click on the summary statistic and then click on OK. And I don't have label in the first row. Click on OK. Guess what? I can easily generate the mean, standard deviation, and so forth, even faster than R. Okay, I have all the summary numbers that I can have than in the R. Okay, so in a sense, I'm not it's okay with me if you would incorporate our output in your assignments and then side by side to your R output. That will be useful too. Okay. Another thing I have to bring your attention is that this standard deviation in our Excel output is a sample standard deviation, and sample standard deviation is different from the population standard deviation. Why? Because they use a different formula. So if you use our function stdev, Excel, and you use .s and then select this range, enter, you'll get the same answer to that, because this is .s means sample standard deviation. But if you use std.p, which is population standard deviation, and you select the range of the data to calculate the population, you assume this data set to be a population, which in fact is not, because the population is usually very large. And you can see the number, these two numbers are different because they use a different formula. They use different formula. So when this is a sample standard deviation, and on the right hand side, this is population standard deviation. Okay, all right, and sample variance, population variance are also different accordingly. You have variance. You see, .s is sample variance. .p is population variance. They both use a different formula. So okay, so these are the tricky details that you need to be aware of. All right. So with that, I think I cover all those important measures for descriptive statistics for covering center, mean, median, mode. We have other measures for center like trim mean. Those are, you truncate the outliers, but not as popular as mean, median, mode. And variability include variance, standard deviation, and probability, and shape, outliers, trend in time. These are the things that we look at and we want to describe graphically and numerically. Once you use the R or Excel to describe these aspects, you are already describing your data graph and numerically. Then using the box plot, dot plot, histogram, histogram that I use, not this one, sorry. Dot plot, histogram, stem and leaf, and so forth to describe your data. You are describing your data graphically, okay, graphically. And we shall see these, if not in this assignment, maybe in another assignment. Okay, actually, if you use R, you can see box plot. But in Excel, you can also have a box plot as well. If you in Excel, you don't have it here, box plot, but but if you use the add-in, if you add another software, analytics solver. I would suggest that you can also use the real analysis. You will be able to create box plot easily. Okay, but for the sake of time, I won't cover it here. Box, where's the box plot? Right here. Right here. You can use R for the box plot to create this box plot. Okay, but there are also other software like a real statistics, which is more powerful as well, which is can be added in your real statistic.com. Okay, real statistic, and you can download it. It's free download, and then you can install it. Follow the instructions. You can install it to do many other works. Okay, you can. There are functions for box plot and so forth, like in here, distributions box plot. You should be able to see it when you open it. Okay, and a lot more statistical functions. This is a good tool to go along with R. All right, go along with R. Okay, let me see. Okay, all right. What else to cover? I believe I covered it in a quick way, but I think it should suffice to cover the material for the week one. If you follow what I just go over, use R. You go to the assignment 1, and you like here, and you follow the hints. Okay. So you go to section 1.81, which are pages 41 to 43. Okay, or 43 to 44. You should have no problem answering these 2 questions. All right, and so forth. I think that should be. Yeah, that should be enough. I cover it in a quick way. I don't emphasize so much on the formula, and I don't require the proof of the formula, because we have so many softwares and functions already available for you to use in order to calculate those statistics. So I don't bother to go over that you calculate them manually. So you don't have to do that manually. Okay. Let me see what others. Okay, I think I'll open up for some questions. Let's see. Any questions? Any questions? Let's see. Hello.
No questions for me, Dr. Wang.
Oh, okay, good. Okay. A question for?
I'm good. I don't have any questions.
Okay. Very good. Yes. Three dot. All good.
All good. Yeah.
Okay.
Fine.
Okay. Look, you know, My approach is, and my philosophy is that I believe my students, they all have a heart to, to learn, and so it's not my philosophy that I give tons of materials, tests, and so forth. So that from that being said, I would say I made this course very doable. Of course, we have some mathematical parts which are not in this section. You will have some mathematical more mathematical materials down the road. But I try to limit the assignments to like 9 questions a week, okay, at most 9 or 10, and so that they won't be too burdensome to you, and you can enjoy the studying and everything. And I don't have the midterm test or final test. I use the project instead. The design is that you do the mathematical assignments. You have the good foundation of statistics and using it for data analytics. But on the other hand, you have the tools, especially R, Excel, and some add-ins. So you have good tools, handy and powerful for you to solve any real-world scenarios, questions that has wide range of applications. So this is the design and my philosophy. Okay, so I believe that you shall be able to enjoy the 8 weeks, and you shall be able to ace it or get your satisfactory grade without without costing you arm or leg the effort.
Good.
I don't know if that's the right way to say it. Okay, but so I make it enjoyable. Okay, and we'll learn substantive materials as well. Okay, let me see. Any other questions? Okay. If no, then we will. Oh yeah, post a brief introduction of yourself as mentioned, and then post at least one one initial post and one response post to the weekly discussion forum. Basically, basically, if you have two this kind of two posts, one initial, one response, you shall get 4 credits. And so each week we only have the 2 deliverables. One is discussion, one is the assignment. And then down the road until week 4 or 5, you shall have midterm art project. And then in the last week, you shall have final project. So and every week you have a weekly assignment. I think that's about it. If I forget anything or you have any other question, feel free to you can post it in the discussion forum, and I will answer your questions within as soon as possible. Usually should be within 24 to 48 hours. And our meeting time will be tentatively said we should be able to meet earlier on Monday, I believe, because this is we just had New Year holiday, but next week we should be able to cover it earlier, and I might have travel down the road, so I will, as mentioned in the beginning, I may use a noon time or 1 p.m. or something like that to start a class. But if you really can't come to a class, I will record. but the recording is limited to 40 minutes according to my personal Zoom room. So, but I'll try my best to not miss to cover everything in the recording as well.
So Dr. Stewart,
Yes.
this is Paul Waterman.
Hi,
I
Paul.
am in Switzerland, so I have a 6-hour time difference.
Oh.
It's actually 2:30 in the morning in Switzerland.
Oh, I'm sorry.
No, that's okay. That's okay. So where will I be able to access the recording?
Oh, I will make it available in the announcement.
Okay, great.
Yeah. Actually, I will be traveling to Europe as well.
Anywhere near Switzerland?
Should be close.
Good.
Okay. Good. So no problem. So maybe if I change it to noontime, I mean Eastern time will be better for you.
Oh, that'd be much better for me.
Okay. Oh, awesome. Thank you. I appreciate your sacrificing your sleep and sorry I didn't know, but
It's
we'll
okay.
try to find a time that fit in for everybody. Okay.
Great.
We will have recording.
Thank you.
Okay, you are welcome. Okay, I think it's a good time to stop, and that's look forward to an exciting semester with you all. Feel free to ask me a question anytime. Okay.
Great.
I
Thank
wish
you.
you have a very good evening and happy New Year. Okay.
Thank you.
Thanks, Professor.
Okay. You're welcome. Okay. Bye bye.